So you see, these are the instances that we have right now. So we still have a single instance, which is relatively slow, and we are only at 34%. So remember that we configured the alarm to fire 60%. So we need to cross 60% for a minute before the auto-scaling action is involved. So another thing that to understand is like none of this is like fast or nimble. Like if you have a system like you shouldn't deploy like an what do you call these stock trading system on Amazon or something. Where you're down to like milliseconds in latency, blah blah blah. Okay. So this is like a fairly trusty and fairly reliable way to scale. But you know, this all takes minutes. So the minimum resolution of the measurement is a minute. And then once you have a measurement, you will work like an auto-scaling action, which also brings up an instance. And depending on how much work you need to do in order to configure it, this can take several minutes. This is also something you want to start using once you have come to know your system. Okay. Because in order to define these policies and rules, you need to know how your system is behaving. Like, should I set the threshold at 30%? Like, if my instances are very slowly coming up, okay, should I set the threshold at 40%, 50%? Or can I afford to wait until my load hits 70 or 80%? The other thing is how much should I scale up if I hit the threshold? So all these questions can only be answered if you have like been in charge of your system and have sort of some history and have a clue how the system is behaving. So, oops. Okay, so we just crossed 60%, so we should be seeing something now. So you see a few clients hammering the server request now in EC. That's how it was interesting. Okay, another thing I want to mention is, okay, there are a couple of flies in the ointment here. Okay, so this is all good, and if it matches what you want to do, what you need to do, you know, it's very handy. So everything that Amazon does is proprietary. So now all of this is closed. It's basically a black box, and you need to put trust into Amazon that they operate well. Elastic load balancers can also fail. Okay, so if you look, there's a very nice presentation about the architecture of the systems that should be deployed in the cloud. And the first thing they tell you is 48 big letters is everything that can fail will certainly fail. Okay, it's not like you deploy it in your own data center where you have like known latencies, known conditions. Okay, this is the cloud is much more brutal. Okay, like Murphy is basically running around with a hammer and smashing things. Okay, so everything will most certainly fail. Yes.
So there is no service level agreement whatsoever. You just
no, that's really
get what you get.
Yeah, it's a best effort. So you basically, the way you architect this, your stuff is you need to assume that failure will occur. Okay, now we see here another instance being brought up. Just here. What's the load doing? Oh, rising continuously. So you see, so we crossed the threshold and we held it for a minute or two, and only then with the instance. So it takes a while for things to come. So yes, so basically any single point of failure in your system deployed on the cloud will kill you. You know, if it's doing it now. So you need to figure out how do I deal with failure scenarios, because they will most certainly occur. Okay. And then obviously there's a cost to all this. And so it's a trade-off. So you can make use of CloudWatch, you can make use of metrics, you can make use of auto-scaling, you can make use of different availability zones, but you will pay. There's a cost to pay. Okay. it's always better than paying $50,000 upfront for data center provisioning, but it costs us unlimited. So I've been looking around a little bit for anecdotal evidence of elastic load balancers failing. So they're like they're forums, they're AWS forums where people complain about things. And so there's a very good like support team which is monitoring these forums or fora continuously. And like I read often somebody says, oh, you know, my auto-scaling action is not firing. And like 5 minutes later, there's a support guy that says, okay, hey, what's your auto-scaling group name or load balancer? I want to take a look. Okay. But there was only one person who complained about an elastic load balancer failing, not running properly. So apparently, you know, they have the stuff sorted out. Okay, now we see instance number 3 coming online. So the load is going to the roof. And a third instance is being brought online.
That's the total utilization, right?
Say again?
That's the total CPU utilization of all of the instances.
It's of the auto-scaling group.
Yeah.
So it's basically the auto-scaling.
Can you show again the utilization?
This one?
I would expect to see it dropping when
Dropping,
you start a new instance, but
Yes, it is dropping, but it is also starting clients.
right. Yeah.
So is it the arithmetic average of load across all the instances?
Yes. Oh, actually, it is dropping. So I still have three clients hammering away, and you see it's the load is dropping. Okay, there's another thing you can do here is, and you can actually look at the alarms themselves. I haven't shown that because it's a bit more messy. Describe alarm history. Let's just take the top 10 lines. So you can see here it says, for example, top line is it failed to execute scale up. Does anybody have any idea of why that might be the case? Why should the auto-scaling mechanism fail to execute a scale up action? Well, one reason could be we're still inside the cooldown period. Okay. And the other one could be that we hit the maximum number of instances. But so this command gives you like a raw. Yes, go ahead.
But there is still no difference between waiting for the cooldown period and having the maximum. So I don't know why it's failing.
You don't know. There's no reason to display. It's a mess. And this is like AWS. While they provide useful services, it can be like surprisingly rough around the edges sometimes. Okay, let's see what's going on here. Okay, so we see load stabilizing, and here we see like 3 healthy in-service instances. Okay, so now because we have actually we said we scale down after we drop underneath 50%. So this is why the scale down is not occurring. But now we are underneath 50%. So eventually the third instance should be shut down. Okay. Any questions? Yes.
Let's say now you have like 3 clients on that, like hitting your server.
Yes.
And they go over a complicated workflow.
Yes.
That involves sessions, for instance, right?
Yes.
So your elastic load balancer has sticky sessions, right?
It has something called session pinning. Like you can implement session pinning.
You can span sessions across the instances? Or?
I believe what you can do is I haven't looked into it, but I believe that what you can do is you can pin sessions
To particular instance.
to an instance or to.
Well, yeah, that's the sticky session.
Yeah.
But what happens now if you have a scaling down?
Yes.
Let's say you have 20 clients that are on a machine that is scaled down, and they have this sticky session on that machine.
Yeah, but why won't you use sticky sessions? I mean, this was 10 years ago.
There are a couple of good reasons for doing that.
Yeah, why?
Why?
Yeah.
Well, so yeah, I know as a principle you shouldn't use sessions, right? You should try.
Yeah, no, that's no problem, but there are things like Memcache and Redis where you can
Yeah.
store your sessions
Yeah.
and
Yeah.
then you don't have to use sticky sessions.
Yeah.
I mean, this is the reason for cloud. Why do you use sticky sessions and have it in the cloud?
Sorry, now you see one instance terminating now here. So, Don, to answer your question, like if for some reason you think you need to use like sticky sessions, well then you shouldn't scale down. Or you should basically, or what you can do is you can remove. Let's say you want to scale down. So what you should do is you should remove your instance, take it out of the load balancer, basically prevent it from getting new requests. Let all the old requests be dealt with, and once it's been no request, you take it out.
But you have no way to monitor that? Like the load balancer has no way to take care of that kind of...
I don't think so. This is something. This is the behavior you need to prevent yourself.
Will it work? I mean, if you take it out of the load balancer, normally every request should go through the load balancer.
Yeah, you're
Because
right.
it's not communicating directly with the machine.
Yeah, you're right. So you can't even take it out. No. I don't know. I can't answer that question. You probably will need to implement some kind of your own policy.
But is it possible to halt the shutdown on the system? Like if you have like some computation running that's important and
Yes.
will be like lost if the machine is shut down. Is
Yes.
there any hook system where you can say stop? I have like a few minutes left.
No. So as I said, this is why you need to, if you have like state. So you have state you need to store. You need to store it either in an external medium like Redis or whatever,
Yeah.
or into S3 storage. These are snapshots. So you're just encouraged to if you have such a kind of computation to take to push snapshots into external storage. Okay. So that everyone is sort of running down. Yeah. So you know, actually see the second instance being like a shutdown, so a good state, for instance. So when it comes to shutting down instances, so what the auto-scaling group does is it attempts to keep the youngest instance. So basically the older instance that are higher likelihood to be shut. Also, sometimes if you have a long-running service, let's say you need to modify the launch configuration. So you have a service that is running for 3 months already, and now there's a need to modify the launch configuration for the auto-scaling group. Okay. So then the instances with the up-to-date launch configuration will be kept, and if a scale down occurs, the other instances with the not so up-to-date launch configuration will be shut down. That's actually.
Just one question. What
Yes.
happens if you scale down one machine manually? Will this also work?
If you shut it down, yes, it will be seen.
Okay.
So you can do it. So number one is you can basically, so there's this big red button, you just push it and say stop auto-scaling, I don't want it. Or you can like suspend it for a while. Or you can just basically, what does Netflix call this? They have like Netflix is like a company, they have like 120,000 servers on Amazon. Yeah, they do all the business, all the movie streaming via Amazon, and they have something called a chaos monkey. So they have software that just shoots down things, and then they see how well the system copes with that. Sounds like a fun thing to do, unless it's your system that's dying. Okay, so here's some references. You want to have a look? And yes, go ahead.
I didn't want to interrupt your thing.
Ah,
Anyway, there have been a number of articles recently on the web and hacker news and so on how Amazon is really, Amazon cloud services are really too expensive.
mm-hmm.
And they are actually very expensive compared to
Yeah.
a normal host your, rent your server by the month.
Yes.
Have you done any look into pricing or so? Can you say?
So I've seen a tweet going around today where a person, I can add that to the references, where a person just rented like a virtual private server and compared memory and performance to Amazon's instances.
Yeah, I've read that.
Yes, and I believe it's like an order of magnitude. What you get
huge. Especially because you don't get you get pretty bad performance for your money.
Yes.
Something we struggle with at work to the I/O on EC2 is just so crappy.
Yeah, and I think so. The reason why AWS is so attractive to many companies is the overall package.
Yeah.
Yes, it's all these services you can get that you don't have to build it yourself anymore.
I don't know if that helps, but we just moved our whole infrastructure from Hetzner to Amazon, and we pay 5 times more, exactly.
That's
But that's
Yeah.
only as good as what we have, but it's
Yeah.
give you an order of idea.
that's roughly what I'm seeing.
But on the other hand, this was obliged by our customers. Actually, they obliged us to move because they don't trust hosters like Hetzner or people like that.
Yeah.
They have a number. When you work with really big companies, they have a number of cloud solutions they trust, and it's basically rack space or
Yeah.
Amazon. And that was it. So.
Yeah.
Yeah, so Amazon, despite some downtime, they had a month ago they did an availability zone going down for a while. And nobody's perfect, but they have a reasonable track record. Given the scale and scope of the resources they provide, they have a reasonable track record. So, and the alternative is to your own cloud, to set up your data center and install something like OpenStack.
Sounds like a little bit more work.
Well, like getting OpenStack up and running, I think is manageable, but you lack all these services again. So what you get is computation and cloud storage. But there's no CloudWatch, there's no auto-scaling. So, and all of this you need to implement yourself. And that is cost as well, in time as well as in money.
Well, and you have to buy the hardware. Right?
You have to buy the hardware, but still, don't underestimate the cost of implementing all this yourself. There's a good track record of implementing
And the
these services.
support that comes with it. And the support.
Yeah.
You have to maintain all this.
Yeah.
It's always a discussion like let things do that you're not professional in, and like pay a little bit more, but then you're like you don't have to care, but
And they have an SLA, which is also important. Like Hetzner, for instance, they have no SLA. If they want to shut down a machine, they just do. And they don't pay anything, or there's no guarantee, whereas Amazon has a pretty strict SLA.
Have you any knowledge about Joint? It's like the other big player in the cloud.
Oh,
But they always compare like the feature rich
Yeah.
Amazon and the like speedy fast, the feature rich.
No, I haven't looked into the other vendors. So basically, I'm focusing a bit on Amazon because of all these services they provide, and I also want to look at OpenStack for other reasons. So I think it's an attractive in-house solution. Yeah.
Is there any restriction with respect to the languages or application service you may use, or
No.
just an image you can put in?
Let's say your machine, and it's like a metal server.
Yeah.
Your operating system, you can do whatever you like with it. And as you saw in this Cloud NS script, you can configure it whichever way you please. So you can deploy your services.
Okay.
So are the instances accessible from the outside individually or only through the...
It depends. It depends how you configure them. So I mentioned the security group, which is a firewall you associate with your instance. Okay. So what you can do is you can say, you can basically tailor yourself which firewall rules apply to which instance. So every instance or every resource in Amazon actually comes with an external IP and an internal IP. Okay. So you can say for this instance or this set of instances, this security group applies, and then they can only be accessed from the internal. You can shield them.
So I could also have non-HTTP
You could.
services or whatever.
Yeah, precisely. If you have something like Redis 6379 or whatever, yes, you go for that. So I encourage you to look at the Amazon AWS Web Console. It's a bit of a monster because there's so many services and it's like a TAD for each service. But like in order to get up to speed, it's not too bad. And once you know what you want, and once you sort of have an idea of all the resources and commands, then you write down and write some scripts. Don't care about the others. So, but I find it interesting. Like again, like every service, every company, they have a good size and a bad side. I find it interesting, like what you can do these days. Maybe something like this. If I have some kind of startup, and I need to get up and running fast, and I want to be scalable, sure. Why would I spend like 2 many years implementing this myself? I want to implement my product. I don't want to work with it. So this is the big attraction of systems.
And obviously there's a lot less vendor lock-in to use like the Google App Engine or something like that.
Well, there's some vendor lock-in because they are the only ones who provide this. Okay. So if you restrict yourself just to computation and cloud storage, then you're much safer because then you could migrate to something like CloudStack. Okay. But as soon as you start using all these nice services, you're locked into AWS because there's nobody else who provides similar services. Hard to switch. Okay.
Still on a different level than lock-in. It's
Yeah.
about the operation
Yes.
aspects. But if you use App Engine, for example, your whole the data
Right.
storage is
I agree.
locked in.
There is this strange database, big table database.
Yeah.
But I mean, they shouldn't be discounted though. I mean, imagine you build a system. You have some kind of system, and you use all these nice auto-scaling things and CloudWatch, etc. Okay, and then you decide, okay, you got bought out, or you got significant investment, and you have money and resources on your hands. I want to deploy someone else. I mean, it's going to be a significant investment to re-architect your system to do all this yourself. So there's some degree of blocking. Can't be helped. Yes.
Have you some experiences with Heroku or similar platforms?
No, I haven't used this. Sorry. So one reason why I'm focusing on AWS, on Eucalyptus. Eucalyptus is like a re-implementation of the main Amazon interfaces. It's open source. Have you heard of Eucalyptus? So I mean, it began as a research project, somewhere in academia. But then they founded a startup, and when Ubuntu came out with the Ubuntu Enterprise Cloud, like 2 years ago, they were shipping Eucalyptus actually. So you could set up your own internal private cloud using Eucalyptus. And Eucalyptus offers EC2, S3, identity management, like the 4 or 5 core services. Okay. And so the beauty is, so you've seen the script of mine, the commands. Okay. The beauty is, if you have an operations person who wrote scripts that target the EC2 API, you just point it to Eucalyptus, they will work. But they're nowhere near complete as Amazon. Also, they also entered like an agreement with Amazon. So Amazon, so right now this entire cloud market is a huge war zone. Okay, because Amazon is the 800-pound gorilla, and they're a big lead. But there are certain scenarios they don't cater for very well. For example, if you're like a company that does like insurance or a bank, you can't pump your data, morning sensitive data, or if you're the military, you can't pump it in the public cloud. Even if you have all the security gurus on the planet, you know, a data leak is a possibility. Okay. So these are all like industry sectors which Amazon AWS cannot cater to because this is the public cloud. So Eucalyptus then came and knocked on Amazon's door and said, hey, you can't sell to all of these people because because they are afraid of their data being exposed. We are implementing your interfaces. How about whenever somebody knocks on your door and has a private cloud, you hand over that contract to us and we'll do it. And this is how it works these days. Yes?
There's a similarity on doing the same thing as well. You can have your own private clouds, but you have a hybrid cloud.
Yes. So this Eucalyptus, but also like OpenStack is also a game changer because it's becoming increasingly easier to set up in your own data center. And there's something called Juju, so which we had a talk on here as well. So Juju is like it's like a service orchestration for the cloud. And Juju can target different kind of cloud backends. You can target an Amazon cloud. You can also target OpenStack. So what you can do is you can write all your software, and then you need to deploy it, you need to bring it up in the cloud, stand up in the cloud. So you need to connect. Let's say you have like you have your own mobile setup with HA proxy. You have a bunch of web servers. You have a bunch of app servers. You have a bunch of database servers. Like you can bring them all up. You can configure them using Chef or Puppet. But then the next step is to connect them all. They need to be aware of each other. HA proxy needs to know where the web servers are. The web servers need to know where the app servers or the database servers are. If you do database application, the master needs to know the slaves, etc. So this is what Juju does. So Juju is a way to basically wire up your cloud service as a whole. Okay. And the nice thing about it is you can say, okay, here's my Juju configuration. Okay. And here's my cloud backend, and Juju knows how to talk to 3 backends. And 2 of these are Amazon AWS and OpenStack. So this will be like a long way out of the conundrum. Basically, stay away from all of this. Forget the second presentation, and use some of the Juju to do it. Okay.
To be complete, there's another, there's a big buzz at the moment, like with OpenStack and other platforms, like with Citrix started, like CloudStack and stuff, and now the community is a little bit divided, and So like we're at the beginning of private clouds, in my opinion. Yeah.
So this one arose because Citrix put down I believe $80 million last year for Cloud.com, and then this cloud because they wanted to have their own. Okay. Citrix is into making money, like others as well, but Citrix is very just fine. Okay. So they bought Cloud.com. I believe it's $80 or $100 million they paid for it, and it's a fairly complete cloud implementation, also in Java. This is also in Java. And then this entire OpenStack thing erupted. And I believe the Citrix sort of didn't know which way to go. But they eventually pulled out of the OpenStack alliance and said, okay, we'll do our own thing. Let's face our own clouds. And apparently they're doing well.
Yeah.
Like many Citrix resellers have high demand for cloud-stack applications.
And in my opinion, they are like 2 years ahead of OpenStack. In my opinion.
Might be.
Yeah. Because we looked into it, and then especially like the enterprise stuff. It's like because like all the big players, they have it's like web standards and stuff takes. Yeah, like everybody has to agree, like this interface has to be like this, and like Citrix can do their own stuff.
Yes. So, I mean, a couple of considerations. So, Citrix's cloud stack came out of one organization, so which can be advantageous. Basically, you have like architectural integrity. Okay. OpenStack is still a baby, really. It's very young. So the community is figuring out how to do business, but also the companies are trying to figure out how to do business. So So I think my personal assessment, like in a couple of years, OpenStack will be a big player. But right now it's sort of shaping up still. But interesting nevertheless.
Yeah.
Okay,
Thanks.
thank you very much for coming.